Facsimile machines were developed to transmit documents and black and white photographs over radio and telephone lines. The satellite weather maps you see on TIE are transmitted this way, as are the wire photos you see in newspapers and magazines. Facsimile technology is a product of the 1930s. The earliest facsimile machines were hand-cranked and used spinning metal drums and brass gears. Later models featured electric motors. Although most modern weather satellite stations use high-resolution digital laser facsimile computers to produce their maps and photos, mechanical facsimile recorders are still the machines of choice among WEFAX enthusiasts. Mechanical facsimile machines are relatively inexpensive, starting at under $100, and can easily exchange pictures with state-of-the-art computerized facsimile machines. Although these two types of machines are separated by more than 50 years of technical advances, the principles behind them are the same. In fact, most WEFAX programs for microcomputers, such as the programs in this issue, are modeled after mechanical facsimile equipment. The heart of a mechanical facsimile transmitter is a rapidly spinning drum. The photo to be sent is wrapped around this drum, much like a label is wrapped around a coffee can. A standard drum measures 152 mm in diameter, about 6 inches, and is at least 660 mm long, about 26 inches. The drum normally spins at 120 rpm, although speeds of 60 and 180 rpm are also used. Since one revolution is equal to one scan line, drum speeds are usually reported as lines per minute (LPM). As the drum spins, a small arm creeps alongside it, moving about 1 inch with every 96 revolutions. The arm carries a small light and a photocell. The photocell scans each line of the image, one dot at a time, and generates a small electric current for each dot. The current is proportional to the darkness of the dot. The transmitter broadcasts this varying current as a varying tone. Darker dots produce lower pitched tones, while lighter colored dots yield higher pitched tones. If we played a musical scale into our WEFAX machine, for example, we'd see a gray scale ranging from black to white. The scale would have to be played very quickly, though. A drum speed of 120 LPM means that WEFAX images are being transmitted at 2 lines per second. A facsimile receiver running at the same speed can intercept these signals and reverse the process to generate a copy of the image. In practice, WEFAX tones range from 1500 Hz. Black dots to 2300 Hz. White dots. WEFAX images also contain a short, dead sector, which corresponds to the left and right margins of the image. This is where the photo is attached to the spinning drum. Since WEFAX transmissions have no timing signals, such as the horizontal sync signals used in TV broadcasts, the dead sector is commonly used to align an incoming picture. Generally, a WEFAX signal sounds very much like cricket chirping at 2 chirps per second. Each chirp corresponds to a single horizontal scan line of the image. A standard WEFAX image is composed of 800 of these lines, stacked one on top of the other. Since each scan line is transmitted as a half-second analog signal, at 120 LPM, it can be divided into as many pixels as you please. Of course, a scan line divided into 800 individual pixels will have a much finer resolution than one which is divided into 8.